Who's ready to share? So that you go and read. We start with the BMI data. You know, it's 2 data sets I sent in addition to the module. One BMI is in SPSS, while the skin lesion is in Excel. You know, it was the skin lesion we used it for yesterday. You know, today we want to look at the BMI to move further. Somebody share the BMI. Dr. Shido, you can share now. Dr. Shido, say.
Yes, I'm with you, sir.
Okay, quickly share if you have your BMI, the BMI data.
BMI. Okay.
Okay.
Let me. I've not opened it. Do I need to share first and then?
No, you can. Yeah, no, you first you can go to where that folder is without even opening SPSS. Double click. When you double click, it will open the SPSS and open the folder. Then immediately you share with us.
Okay. Or I can. My SPSS is open. I can go through SPSS at once.
Yes, you can go through SPSS as well. Yes. So if SPSS is open, you can even share with us before you go and open it. You can share once you have opened your SPSS, share it with us, then look for it. Yes.
Okay, I'm almost there.
Okay. So that will start from there. You know, we were able to do transformation yesterday. Yes.
You said you disabled participants screen sharing.
Okay, sorry. I'm not enabled. Okay, you can do it now. So we did transformation, log transformation yesterday. That's not the only one. You can even square something. You can do the root through that process of transformation. We want to start with computing new variable now. Okay, that's great. Okay, go to, everybody can see. Go to view after edit. Click on view.
Yeah.
Yes, click on it. Then come down and click on value labels. You will see something now. That text that is 112 will change to the value.
This value label.
Yes, click on it. Can you see? So if you look at it, the group, those ones are categorical variable there. Because most of the variable here, they are quantitative in this BMI data. But the two that are categorical are the group, urban, rural, and the sex, male, female. So if you look at it, it was 1212 that were written there. Now it just changed to the value. So, you know, when you do your value, you know, in your data, in your variable view, you put the value to, you know, label your value. It depends whether the label is going to show or not unless you click on that view. So sometimes, like me, I don't like it like that. So I prefer removing it from the view.
Excuse me, please. I'm not following. Okay. Can you take it?
No problem. That's Dr. Shido, right? Okay,
yes, sir.
Okay, you say you are not following. Oh, okay, it's Prof that says it's not following. What I say is that go back to that view. Look at the view, what it's doing. Look at group and sex. Group and sex. Yeah, click on the view. Click on the value label, uncheck it. Can you see? The group is now one, because there are two groups here, urban, rural, and they are coded 1 and 2. So for the categorical variable, the code are showing. If you want the value you put in to show, you go to the view and check that group label. That's just what I want to show you. If you go to variable view, and go and see, go to variable view. Variable, not data view, variable view.
Okay.
Yes. If you look at group, go to look at the other value. Come and click under the value. You see it's urban rural. Click on it. No, you are not there. That's not the one up. Urban rural. Can you see urban rural? That is the value you set for the group 1 urban, group 2 rural. That is, you code the group 1 as urban, group 2 as rural. Okay, we are close it and click on sex. You see the same thing. Click on sex. Close that one and click on sex. It's male, female. 1 male, 2 female. So those are the only two categorical variables in this data set. Close it. So go back to data view, what I was showing. So if you look at it now, it's why nobody knows. You don't know if the label is, but if you want to know, or you want it to show the value of the label, the value, you click on the view and click on the value label. When you click on it, you bring the value. I should do it again. Yeah, click on it. Click on it now. Check the box. What's happening? Hello? Can anybody hear me? Can anybody hear me? Hello? Sorry, the network just went off. Yes. Okay. Let's do something. Now, we know we have here, we have some variables that we can know. Most of the variables here are quantitative variables. See, this is for BMI, but there's no BMI here. So we have height and weight. We want to define BMI. It's the same thing with the way we did log transformation. If you look at it, when you go to that place under transform and compute, you see the keyboard there, just to write the equation you want to write, and it does it for you. So compute, BMI is weight over square of height. Click on it and transform, compute. You want to compute. The target variable is BMI. Okay, type it, BMI. Now, let's go to the expression now. You don't need to label it. If you want to label it, you should type, you want to give it another name. So now, the BMI, the expression is weight over square of height. Okay, move weight into that place. Now, divided, yes, that's divided by. Okay, click on the bracket. Before you do that, click on the bracket. No, the bracket is down here. Yeah, click on it. Now, move weight the height there. Times asterisk. Asterisk is times. You see asterisk. After minus. Go and move height again. Go to my height again. So, okay. So the reason I put bracket is that, the BMI is weight over height times height. Both of them, they are under the division. If you don't put the bracket, if you say BMI is going to weight over height, you now say times height without the bracket, showing that the bracket is for the two height. What it has done, you have not moved. It's the value of weight that it will give you, because you times divided by height, you now say multiply by height. So the height, the second height will be a numerator, and when you divide it, it will just cancel out the first height. The value of weight is what is there. Can you see? You remember board mass. So sometimes when you are doing your calculation, you have to cross-check that you are doing the right thing. Otherwise, you think you have put the right thing there. it's the wrong thing you have computed. And that is why, because the weight is divided by height times height. That's why I put that division and I put bracket. That height times height, both of them are under the division. Okay, click OK. Click OK. Click OK and share with us. Okay, well, so don't share anything, please. We have no, sorry. Go to the extreme end. Sorry, no, I'm not sharing anything. Go to the extreme end of the data area or this variable view, data view. Go to extreme end, you see the BMI there. Scroll to the right side. Hello? Yes, can you see? This is BMI. As naturally, you know, SPSS, it will give it to 2 decimal places. When you do any calculation, any new thing, you give it to 2 decimal places. And I think it's because of something like this, they did that. So we want to, and if you see the way we can, if you want to multiply something by, you want to do square transformation, this is the same thing. Let's say I want to do square transformation of respiratory rate. I just say respiratory rate times respiratory rate. That's all. Multiply by respiratory rate. That's the square transformation. If it's the root, then look for the function of the root there and do it. So anything you want to do here, calculation, whatever, this is under the transform and compute. So now I want us to range that the way we range the age yesterday. I want us to range BMI because BMI is a special one in the sense that there are some, the reasons I want us to do that is that it has some decimal there. If care is not taken, if you don't know how to do it very well, you do the range and you will omit some. So we can remember our description, what is BMI, definition of BMI, and the categorization. I think the first was less than 80.5. Okay, let's go to, yes, less than 80.5. The 80.5 to
24.9.
24.9, yes. Okay, let's go to the same transform. This one now is, you go to not compute, recode to different variable. You want to recode that BMI now to have a range so that you can tabulate it. You want to tabulate that so that you can put in a table. Yeah. Where are you? I say recode. Okay, yes, recode to different variable. Yes. So move BMI to that space. Now, okay, the target variable, the attribute variable will be BMI group. Come and type it there, BMI group. No gap. Change. You now click on change to move it to that. Yes. Because if you look at it, before it says BMI to what? Question mark. When you now put BMI group, that's what you are coding BMI to. Now click on change to move it there. Now click on hold and new. Now click on range. So we don't know this. If let's say you want to know the highest value or smallest value, if we have summarized it, we'll have a better, since you can put 0, start from 0. I think it will capture, because if you have run it, we just run the frequency now, or no minimum amount, we know where it starts from. But no problem, since it cannot be less than 0, it cannot even be, to that, but let's just put 0 to 80.5, 499. Since the also, yes, because it's less than 80. So 49 or 499. You make sure, can you see now? You can put 49 or 499. You know this thing there is to 2 decimal places. So you capture, you make sure, don't just put 18. You just put 18 or 18.4 or 18.5. There's a possibility you miss out some things. Though if you put 18.5, anyway, you say less than 18.5. So 18.4 now, 499 is okay. Now, okay, continue. What do I say? Put value. Come to value here and put 1. Then add. Then go back. Now from 18.5 now, then through 24.99. Well, 99, please, because there are 2 decimal places. So we are going to pick the other one from 24.5. 99, yes, okay. 2. Okay. Then from 25 to 29.99. 3. Then from 30 to 39.99. So this one is from 40 and above. Put 40, just put 100 to 100. No, I don't think any of them will have VMI 100. It's just to capture whatever the highest you have. Click, put 5, and I'll continue. Okay. Scroll to the side. To the side, you see, can you see the BMI group is there? Yeah, we have seen it. The BMI group. So if you run it now, you can go and remove the 2 decimal places there. Collapse the decimal to 0. I thought you went to yes, to variable view, you do 0, 0. We are increasing it. Yes, okay. Now, you need to label it, but run it now. First of all, run it because I want you to see. If you run it with your label it now, is the number it will give out. Go to what I mean by run. No, there are 2 groups here. Okay,
So
don't worry, first of all, run it. I will ask you to go and split later. Run it, go to analyze. I want to do the frequency of BMI.
Okay, analyze.
Go to frequency. So move the BMI group. Okay. No, okay now. Is the frequency you want to do? No. So you have to go and share the output with us. You have to uncheck and check. On share and share. Share. We cannot see the output. Share the output.
I'm coming, sir. I'm doing it now.
Okay.
Can you see it now, sir?
You can see it. That's great. So if you look at it, it happened there's no one that has BMI less than 80.5. That first group. Can you see? And we have BMI, the other group, 80.5 to 20, 24, 24 to 29, 30 to 39. So there's no one that has no gross obesity. Right? So if you look at it now, if you leave this data, you save it, very soon you may forget that what do you put as 2? So what you should do, go back to the data editor window. Share the data editor window with us. And let us go and label the BMI group we created. Go to the data. So, great.
I'm in the data view now, sir.
Yes, I can see you are there. So go to variable view. Go to variable view. So under these values, click on value for that group and put it. So you put 2, you know that 1 is not there, so you may not bother yourself. 2, or you can put it, you can still put it label, at least for people to know that is for you to know what the first group mean. 1 less than 18.5. The sign of less than is there on your computer here, sir. You had 2 is 18.5 to 24.9. Add group 3 is 25 to 29.9. Group 4 is 30 to 39.9. And group 5, even though you don't have it there, greater than or equal to, is not greater than or equal to 40. You can type greater than, also type equal to, or if you want to get that sign, you have to go to Word document, pick it, type it in Word document, click it, and now copy and come and paste. That's what I usually do. That sign symbol greater than or equal to, I go to Word document, I click it, and now copy and come and paste it. Okay, that's great. Okay. Click OK.
I've done that, sir.
Yes, I want us to rerun it, but this time I want you to go to, I want you to split, because this data set is for 2 is urban rural. So I want to run it urban rural. I click on data.
Sir, I want to ask you.
Okay, go on. Go on. I'm listening. I'm listening. Can anybody hear me? No. Okay. Yeah, that's great. Hello, sorry. You said you were asking a question, please. The network just.
Yes, sir. I noticed that the BMI group has now changed in the data view.
Yeah, you know that you what is it? It's you that you know you have already set on that view now. You remember all the categorical variable there are labeled. Look at it now.
Okay.
You just label it now.
Yes.
And that's the label you put now.
Okay, I thought it will show the individual. Okay, it's a label. Okay.
Yeah, it's a label. Go to view if you want to turn it back. You know, the other time you put it in on that view. Go to view and uncheck that group label.
Okay, yeah.
Yes, yeah. It's because of that now. So the essence of you labeling, if you have done it now, you save it. You know, when you are running it again, you know, or when you even run it, the value comes out, you'll be able to know what 1 mean. What does it 2 mean? What does 2 mean? Somebody want to ask another question? Dr. Taiwo.
Okay, it's clear.
Dr. Taiwo, are you asking a question?
No, I'm not asking a question.
Okay, that's great.
Yes, sir.
Okay. Now, we want to do something also. You know what I was saying yesterday when we talk about Boolean logic? Here now you have, even though we don't have history of hypertension here, then we have systolic and diastolic blood pressure. So we want to know, okay, who is hypertensive? Want to identify. It's not straightforward like the other one, like diabetic. Diabetic is only one value, blood sugar. Just like what we did for CD4 count and viral load yesterday, where we just okay, CD4 count less than 200, just have it like that as high low CD4 count, or viral load greater than 1,000, just have high viral load. But hypertension, want to define somebody that is hypertensive now. It's not only one measurement. It's not only systolic. Diastolic is there also. So you take it's either of them or both, or either or both. That shows that if one person has systolic hypertension, it's hypertensive. If he has diastolic hypertension, it's hypertensive. In fact, if let's say in the data set there is history of hypertension, so anybody that have history of hypertension, even if the systolic and diastolic blood pressure are normal, the person is still hypertensive. So in that case now, you have to select the three. We want to select hypertensive now based on two variables, systolic and diastolic blood pressure. So what do? Go to data. This is what I call the Boolean logic. Go to the select cases. Yes. And by default, all cases, we now click on if condition is satisfied. Yes. So move systolic blood pressure inside. Then you say greater than 140. Now press space. Press your space. Then you now type or with your hand. Type or. If okay, yes. Yeah, go and pick that diastolic blood pressure also. Greater than 90. Yes, it's okay. If let's say we have history of hypertension, we not say or history of hypertension. Yes.
I want to ask.
Yeah, go on.
Between the systolic blood pressure, should there be a space with the greater than and the 140? Like this one that is close to.
Either we put face of it, I don't think it will reject anything. But normally you should not put space. Apart from the one computer, if the computer give it, the examiner, as you press, yes. Okay, if it's not going to go, whichever, if you click, it will not go. But if it goes, it's okay. Okay, click on continue. Click on continue. Click OK. Yes, can you see? Yes, you can see your that can you see it crossed what you did yesterday? Those one that are hypertensive that have any that is satisfy any of the condition of systolic greater than 140, diastolic greater than 90, they are the one that are not crossed. Any other person that are outside those conditions, they are the one that are crossed. So if let's say you just want to select it for further analysis, now you can just go and do your maybe just want to do analysis. There is beyond that you want to select it for analysis to now analyze, do some analysis for those people that are satisfied with that condition. It's not only that, you want to even create that variable that these are the people that are. Sorry, this, I don't know what this network here. So now, let's go to variable view now. Let's go and label it. Variable view. Now, go to change that into hypertensive. That filter, leave it as hypertensive. Now, you remove this one that label, cancel it out. Then click on this and change to yes and no. Yes. Change. Click on the that one. Yes. Change to. Okay, that's great. You have done that. So you have created the variable now. So you can now you go back to data to say if you analyze for. Go to data. Data under go to data. Then select cases. Select cases.
So you said
No, what did you do now? Okay, so yes, you are there. Just do yes, you are right. All cases. Click on all cases.
okay.
Okay, click OK. You want to go back to to analyze. Okay, because if you don't do that after you have created the variable, if you don't do that, it's only those people. If you are running any analysis, it's only for those people that satisfy that condition. Those for hypertensive people. I don't know if you get it now. So go to analyze now. Go and run the frequency. Let's see. Let's see the distribution of people that have hypertension.
Please, sir, I have a question. Why did you? Because since you were okay, when you finish. When
Go on with your question, huh? Ask your question.
Like, okay, sir, because I know that the whole idea of trying to, select, the systolic of 140 and diastolic of 90, so you're trying to at least extract or get the ones that's likely hypertensive. So that was why you. Hello.
We are listening. Go on.
And that was why you selected you did you select them. But now I don't know why you're going back to. So, because I didn't understand why you now went back to say all cases again.
Two things. You want to select them so that you can do further analysis on those one alone. You have to leave it like that and go and run analysis. But that's not the only function. You can do that, and even if that is the function, when you finish you running those analyses, you go back to remove it. But the second function, we want to create a variable so that you have a variable that says hypertensive, yes or no. Do you get it? And that is what we have done. And we are finished doing it, and that's what it's already there. If you go to look at the last column now, it's already the hypertensive status, yes or no, is there. 1 0. 1 is yes.
So that was what you did after when you did that select cases where you were doing the systolic of 140 and the diastolic of.
Yes.
You went to create, you went to the label to do that.
Immediately you see a filter. It give us their filter, selected, not selected. You now go to the data variable view and change that filter to the name. That's it. You change to the name of the new variable you are creating, which is hypertensive. And the value that is selected means 1, not selected 0. 1 means yes, hypertensive, yes. 0 not selected means.
I know.
So you now change the name. You change the name there. So you have created a new variable, hypertensive, yes, no.
Oh, I see what you did. Okay.
That's great. But however, it's still good to do something. Because
so even if you now go back and you now unselect, that you now select all, you still have that your variable. It still is intact in your data.
Because even when you have your variable, if you don't go and return that thing, when you are running, it's only for hypertension to come out for you. And whereas you want to analyze everything. After all,
keep on running. Okay.
After all, even you want to know,
analyze
you want to know yes, you want to know no, also you want to know that those are yes and those are no. But if you don't go and stop it, it's only the yes that it be bringing out. Yes, I mean now. So now,
Okay.
you know, I told you like let's go back to what we did to
Yes,
the
sir.
BMI. Yes.
So is it the same? Can you also do it with the way you do when you want to say you want to create new from different variables, something like that?
Is it the one we did BMI?
Yes, with BMI.
No, it's different. If you look at it, BMI has to do with calculation. That one is mathematics. Anything that requires the mathematics, you go to transform and compute.
No, what I mean is this part of transform and then going down to recode into different variables.
Okay, that is different. I've already told you. Whenever you just want to have anything, yes, no, 2 categories is
Yes.
data select you do. But if you want to now have more than 2 categories, you now go there. That's what I want us to do now. Let us, you know, sometimes you table your this hypertensive, systolic, less than less than 120, then 120 to 140, and greater than. Okay, even the hypertension, is it greater than 140 or is greater than or equal to 140? Well, the clinicians, how do you define the other time? You know, so.
Okay. First, I just wanted to mention that if now that you just explained it, it now makes sense. That means you can't even use recode into different variables to compute hypertensive. You need to, that is, you have to use the actual compute because both of them go together. It's to be both the systolic and the diastolic. So that is why it requires the compute aspect.
Which compute aspect? We have not.
Where you have those functions.
No, we didn't. We have not even used them for this systolic and diastolic. We have not used them. What we just did is to go to data. That's what he did. Go there, Dr. Shido.
Okay.
He went to data.
Because I remember him going to one place that now had those the things that look like calculators.
And the same place, it's the same thing. That one also look like that. Don't worry. Go to that select cases.
Yeah.
Select cases. Either you go to transform or select cases, it will give you.
Excuse me, sir.
Yes, ma'am.
Excuse me, sir. Sorry to butt in. I think that if you maybe if you slow down a little and try to clarify or get Dr. Gunaya to demonstrate, because we have done 2 things now. First, we have transformed and computed for BMI by using weight over height squared.
Yes.
That was using the transform and compute.
Yes, I get that one.
And we did select cases. So we selected high systolic or high diastolic.
Exactly.
So it's like 2 different functions.
Exactly.
So maybe
it's not the same place. That's what we are saying now, Gonaya.
That's what I was exactly trying to ask. That's like okay.
Yeah, Dr. Gonaya, it's not the same place. The first one for the BMI is like mathematics, where we went to transform and compute.
Exactly.
That's the mathematical one where we use height and weight in that thing that looks like a keyboard of the keyboard of calculator, something like that.
Yes.
Or to select cases of hypertension based on the definition of systolic greater than 140 or diastolic greater than 90 is under data.
Oh, I remember you went to select cases.
Yes. Okay.
Under data, not under
the one that says if.
Yes.
Okay. Why can't you use your own computer?
Greater than 140 is met. Yes, you're right.
Sorry, now I understand it now. I remember. I remember now. I remember now.
Your own computer.
Thank you very much. I really appreciate it. Who was the one that explained this? I don't even know her name.
Okay.
Sorry, I wanted to know your name.
Your co-learner now.
We
have been together since.
But really tried for me. Thank you.
Okay, Shido. Go to that data. I just want to show something. Go to that data.
I should go to
data. Where we went to go to the select cases. Down now. Select cases.
Select cases.
That is the second to the last. Click on that if condition is satisfied. and open that thing. Click on that if. What I want to show, it will bring the keyboard out also. Can you see?
Oh, I've seen it.
Yeah, it bring it out also. Even if you go to transformation, it will give the. It's only that for different things. So if you want to, this one is to break something into two. You cannot break something into more than two groups here, because it can only allow you to do greater than or equal to, less than or less than or equal to. You understand me now?
Okay, okay.
So it will not allow you to do too many.
More than two groups.
Exactly. So more than two groups.
Okay.
So yeah.
I now understand. Okay. So if for example, you now, anyway, I know that's where you're going to next, Sha. That's why we're saying recode into different variables.
So just come out of this place. Come out. Just cancel it out. Come out of the place. You can say continue if you want to. Go to all cases, please. All cases. Click on all cases. Back. Okay. Now go to transform. So we want to, that systolic blood pressure. Let's break into three categories. Go to transform. Hello?
Okay, sir, I'm there, sir. Okay, it's on the other view.
No, you see, we are seeing it now. The transform, yes. Yeah.
Transform now.
Recode into different variables. Click. Now, you see, now, you now say, okay, you see what you're doing now? So what you're going to do now, we want to recode, move that BMI, move it, click on that BMI and return it. Or you can even cancel it there, yes. So what we are moving in now is systolic blood pressure, move systolic blood pressure in. And now type SBP group, systolic blood pressure group. Okay, that's great. Yes, click change. Click on change. Click on hold and new. Surprisingly, you can even make use of even all this, all the one you did last is there. Click on one, you see what you can change it to your own pattern. Click on that number one. Click. Yeah, come here. 0 is okay. Come here. Put yes. Put 120. It's blood pressure. It doesn't have decimal with the entire. Just put 120, 119, because the normal usually say between 120 to 139 to 119. So click change. Thank you. Click change. Can you see it has changed and move it downward? Can you see? Click on number two. Number two up. So click 120. Then move to 129 and 139. Is it 139 or 140? If we define what is the systolic blood pressure, hypertension, is it inclusive of 140?
Yes, sir.
It's inclusive of 140, right?
Yes, sir.
It is.
Yes, sir. So that the other one we made mistake. When we are defining, you are supposed to say greater than or equal to 140 and that's totally greater than or equal to 90. Sure, you get it now. There's no problem. So 139. Change. Click on change. That's it. Click on number 3. 140. Then this one, we don't know. I don't know if anybody have, or just put 200 there, but nobody have up to 200. Because normally, if you are supposed to first run it to know the highest level so that you can capture on a change.
So can we also do range value through the highest? If you're unsure of the highest value.
Yes, you can. Yeah, you can do that. You can do that. But just you can do the range through there. That will be the first one will say from the lowest, then the second will be range through the highest. Yeah, if you are not sure. But if you can, sometimes you can put a value. But it's okay, we have already done it now. Now click on number 4. Remove. Click on number 5. Remove. Click continue. Okay. Okay. So if you scroll, if you look at this, can you see now? Systolic blood pressure group. So you can go and label it. You go to data variable view. Variable view. Label it. Reduce the decimal to 0 and label it. So Dr. Ugo, so you have never, since you have been doing, you have never demonstrated with your computer. So is it a taboo that you should demonstrate?
I have. Oh.
When? There's no
So I have. You don't remember? I have. It's because I don't want to take it away from the people, the main people that are supposed to be for this session.
Okay, for you.
This,
so you are.
Because I know how to use. You know, I've been SPSS. So like, so I look at because I know that I know myself. Once I'm doing it, I'll probably keep doing it.
Okay. Who has not done yet? So that we relieve Dr. Shido's here. Because yes, see the way he's doing it now. Yes. No, you are going to say greater than or equal to 140. That's like the people that are participating, you will not say 200. Greater than or equal to 140. You will just change it. Okay, okay. Yes. Now, the other thing you need to do also to make your work neater is look at the measure, under measure, the column, go back to that variable view. Under measure, you know it's nominal. So you change it to ordinal because once you range a categorical variable into more than 2 categories, it's ordinal. The same thing with BMI. No, hypertensive is nominal. BMI is ordinal.
Yes,
BMI.
sir.
BMI, change the BMI to ordinal also. The BMI.
BMI group. Okay.
Yes, ordinal. Because you have more than 2 categories of it.
Okay.
Yes, you have more than 2 categories. It's ordinal variable in that sense. Now, you can. Now, I want us also to, let's see. Okay, I want you all to do something, try to summarize, plot some graph out. Okay, now go back to that data and group. Collapse the group. No, don't split. Split file. Go to split file. So okay, it's already in analyze all cases. No problem. It's okay. Just click OK. Okay. I thought maybe you have splitted. Okay. Now, so go to analyze. I want us to do sex and plot graph. Where go to frequency. Move sex in. Click on chart. Chart. Under chart. There's chart under statistic, yes. Click pie chart. Click continue. Click OK.
So can I ask a question concerning this chart? You know, there's some of these rules concerning what you can use for what. You know, for charts, you know, there was a time you were saying you can't use it for things that don't add up to.
Okay, so those are the issues, and we advise everybody here to subscribe to
Yes,
go and get all the lecture video and watch it, because all those things we discuss them under descriptive statistics. So I will explain it now.
that is true. Yes.
We discuss under descriptive statistics how to summarize. I say that the discrete variable, the graph you plot for them is either pie chart or bar chart. Discrete variable, but it's continuous variable. You plot histogram, all this stem and leaf, all those things we were doing yesterday, stem and leaf, box and whiskers, they are for continuous variable.
Okay.
Now, the discrete variable also, you cannot just use, pie chart is not for everything. Like for example now, pie chart is for something that is mutually exclusive, in the sense that like sex now, if somebody is sex, is a male, it cannot be a female at the same time in that group. So anything that had up to 100, that is mutually exclusive. That is what you use pie chart to do. And it makes sense also whenever the category is not many, you can use price, because if the category is, even if they are mutually exclusive, if the category are too much, it's not tidy to use price chart. But if something like symptoms, when you talk about symptoms, you cannot imagine all the symptoms, they are independent variable. You cannot, when you make mention of about 5 symptoms. But the fact that you have weight loss, okay, let me just say generally, whenever there is multiple responses, when you say tick as many as possible, all those yes or no, you tick as many as possible. If you want to represent all of them like that, you cannot use partial, because when you had the initially, it you had more than 100. So in that case, you use bar chart. Yes, even though it's a discrete variable, you use bar chart. So in this section, what makes sense here is to use pie chart for set. You can use bar chart, but to me, it doesn't make sense to use bar chart for set 2 categories. They are using bar chart. They use pie chart. Let's see. Let us see the pie chart.
Thank you very much, sir.
So at the same time that you are running the frequency, you give the pie chart. If you look at it now, the old, maybe version 20, the old, all these old version of SPSS, the chart, they are not as fine as what they are having now. Before, the chart are not neat, but of course they have improved on it so that the chart comes out colorfully. But it is easier to use SPSS to plot this chart. Like this one, all you need to do, screw up. Let's see the result very well. Screw up small. Screw up small. No, just show the graph and the result and the sex and the table ahead. Yeah, can you see here? 44 male, 26 female, make us 70. Or you just go and type it. You see in Excel and type. I hope people know how to draw this graph in Excel. Everybody knows how to draw it. I want a response, please.
Yes, it's simple. Simple to do with Excel.
No, it's simple to do. It's not everybody that can do. I mean, that's what I'm asking.
I have not done it
in Excel before. Eh?
No,
okay.
Yes, sir. I've not.
Okay, let somebody open Excel and share with us. Okay, stop sharing for the 46. Stop sharing.
Oh, okay.
Let's
okay, sir.
Okay, you want to ask a question?
Okay.
Excuse me, sir.
Yes, I wanted to ask a question.
4,719, right?
That how do you
all right, how many facilities?
How do you label the pie chart now in SPSS?
SPSS.
How many?
Okay,
like this, yes, like this pie chart we have now. I'm seeing a particular percentage that is male and then a percentage that is female. Now, looking at this, it's only the color code that is telling you, what number, is male and which one is female.
There,
But
there should be a way you label it. You go back there. Go back. Okay, let's see it. Share again. Share again. Let's look at it. But all those things are very simple with Excel to even do. But let's see here. It's supposed to give us the something. You can label it. You can label it. We open into somebody is making noise. Who is that? It's Jane. It's your own end that people are making noise. Okay. Share again. Let's see. Share again. Yes. Share that result view. I will show you. You enter into that chart editor window. No, I told you at the beginning that when you open a data set, it will open two windows to you. Data editor window and chart editor window, right? So in a result window, double click on that graph. It's done.
Okay, it's coming up.
Can you see that? So this window, new window is opening to you now. It's chart editor window where you can edit your chart. So I think there should be some things you can do here. Right click, create edit script style, edit content. Let's see that edit content. Yeah, in separate window, click on it. Let's see.
Can you see the window?
We see the window. We are seeing the window. No, we cannot see the window. It's the way to.
Let me share the new window.
No, wait. The new window is here now. That's what we are seeing. Okay, you see another window. You open another window for you?
Yes, sir. It opened another window.
Okay, share it with us. Share it with us. I thought that's what we are seeing.
Can you see it now?
No, you see, this one is the. Okay, can you type any edit? Click on edit. Click on edit here. Up. Properties, send options.
Text box. There's a text box here.
Text box. Okay, click on it. Click on it.
Okay.
Okay.
So I can type
in the mail, under mail. I think that one is under the mail. Is it covering the mail? Actually, there, if you go and explore it, I don't want you to do it to waste my time. If you go and explore, you can change things in this place. Just leave it out. Chart editor. Okay. If you look at the name of this, is chart editor. Can you see? This is where you can edit your chart. So if you click on option, click on that option. Let's see.
It's not highlighted.
Click on element. Click on element. Let me see.
I think I have to type something first.
What is it?
I think I have to type something. Let's say mail.
Okay, yeah, type. And you can put the percentage here.
I cannot remember the percentage now.
No, the value is for 44.
44, okay.
Over 70, yes. 44 over 7, you can now put the percentage in a bracket. 44 over 17 is 62.9. Put in brackets. Brackets 62.9%. Percentage, yes.
I pressed enter now, so it has fixed.
Yes. Then yes, the other one. Anyway, there should be a better way. Let's see, which one did you click that was here? Is it under edit? Is it edit?
Okay, I can now drag it.
Okay. Okay, you can drag it inside, yes, yeah. No, you select the edge, you make it a yes. Is that blue? Yes. Okay, so you do the same thing though for the female. Sometimes you same thing for the female, and yes, you can even drag it to the female something, or you can type first female, and you can
I don't think I
separate.
can do that.
And you can even put the female in another line, enter. When you put female, you type female, enter, so that the value will be under another line, and then put the percentage in front.
The enter does not work, sir. Once I press enter, it's clear.
Don't worry. Don't worry. Do it now. Just do it the way you. So the issue there is that once you double click on the chart, you can edit it. You look for the way to edit it. That's it. Because it will open you to another window, which is chart editor window. Even in your result also, you can double click on the table. It will give you to table pivot window, where when you finish, you now come out of it. It will show the chart in a different way. Where is the value? You didn't put the value.
I can't edit it again. I'm finding it difficult editing the female again.
And there must be something. How can you? Okay. Double click on it now.
After I press enter, it became difficult.
And maybe you have to go, and maybe you have to restart again. You have to cancel it and restart and go and enter new. You can cancel it out and go back to that edit. Talk about text box again. Sure, you understand me?
Okay.
Okay, no problem. Everybody, just close. Just close.
Ask a question, please.
Just close. What is?
Take us back. Can I ask a question, please?
Ask your question.
Yeah, I'm working now, sir.
Ask your question, ma'am.
Leading up to this pie chart. So leading up to this pie chart, I noticed that it splits files. Then you asked him to go back again and analyze all.
Yes.
From data, he split files for sex and then went back again. Went back to all files.
Anyway, the issue there is
that from the split that we are having the male female like this.
No, it's not from the split. In fact, if we split, we didn't split.
Can you hear me, sir?
I can hear you. We didn't split. We analyze. So if we have splitted, it will plot two pie charts for us. One for the we have two groups. We have two urban and rural. It will plot pie chart for urban and pie chart for rural. I don't know if you understand me now. We didn't split. Are you listening? Can anybody hear me?
Yes, we can.
So yes, I can hear you.
Yes, we can.
Yes, sir, we can.
But Dr. Lagyo that is talking, he's not responding. That has the question, she's not responding. So we didn't split it, we analyzed all together. You examine, we just analyze as if it's one. We're just demonstrating. If let's say it's comparative now. If it is comparative, I will not allow you to do will not use pie chart. You know what we will not use pie chart. If you want to do the two together for the sense, I will do bar chart. Because you can put bar chart side by side. If you split now, you do pie chart. It's going to do two pie chart for you. It doesn't make sense. I don't know if you understand me. Okay, Dr. Una. Dr. Una. Dr. Una. Please unmute yourself if you want to. If I'm calling you, you have to unmute yourself for me to hear you. Dr. Shidozie. Can anybody hear me?
It will be better. Okay, if not, maybe you can share your own screen, then he can guide you through it again.
Okay.
But what you did was all, not you remove the split, you remove the filter for split.
Yes, he removed it to all.
Okay, Dr. Shido, stop sharing. Stop sharing.
Okay, sir.
Okay, let Dr. Olaglu share our own. You have your this in there, the data set, DMI. Share with us. Share the BMI with us. Dr. Olajuwon, unmute yourself. I will not hear you if you are talking.
Sorry, sir. Sorry, I was my mic was muted. Sorry. Okay. So you said BMI.
Yes, the data file. I think I share with you also how you do have it.
Yes, I have it. I want to show it to you now. Can you see it, please?
It's coming up. Yes, we have seen it. Now, if you go to everything, I'm sure everything there's no, we have not split anything. So go to that analyze, go to analyze and frequency. Yes, and the sex. Click on the chart. Or you have done it before. Click on the chart under statistics.
Oh, okay, maybe I've done it before. That's why I can't even find the sex here again.
So sex is there. It's already there. You have
already. It's there already. Okay, so
click on the chart.
Chart.
And you are doing five chart. If you look at it, we didn't split anything and just continue. And okay, that's why it's only one. This
is what is my concern. It's showing like this.
You know, she should give us your output. Share your output with us. Share your result with us. Result view.
Can you see it now, sir?
We have not seen it. Is he giving you two? You know what you did? You know what you did?
No, you know did? No, I don't.
You went to split file based on sex. Now go to data. Click on that data.
Yes, I'm on data.
Go to split file. Can you see? You compare group with sex. You have split your file with sex.
Okay.
So click on all cases. Click on OK. Now go back and do it now. It will give you only one. And you will not give all this bizarre something. Because when you have split something,
it's really
and
bizarre.
you are saying you are breaking into two. So just click OK. You have already done. Just click OK. Scroll down. Can you see now?
Can you see it?
Yes, we can see it. Scroll down.
Okay.
Can you see? Look at it. But now, you know there are two groups. If let's say I want to do it separately for it's urban and rural. So what I will do, I will not go and do, because if I do it, it will go and give you two separate batches. Okay, go to data back, go to data, and go and split based on group. Go to data, split file. Okay, compare group. Remove the sex, remove this, no, remove this and yes, and put group there, yes. Okay, so go and do the same thing. Go to analyze and do the same thing. See what you will do for you. Just say okay, because all the information, just say okay. Remove group now. No.
Is it not? Is it group you're doing? I think you have done sex.
I'm making mistake. Return the group and put the sex there. What concerns you? The group is urban rural. You want to analyze based on urban rural. So you want to analyze your sex based on urban rural. Then click OK.
Okay.
Click OK. Can you see? You did the frequency. Can you see? Urban rural for you. Group 1, group 2, male, female. Go down. It will plot 2 graph for you also. Go down very well. Can you see? 1 for group 1, which is urban, 1 for group 2, which is rural. But it doesn't make sense. You're having 2 charts. 1 for this chart is for rural, this chart is for this. So what you can do, you can rather do bar chart. Yes, go now. Go to. No, before you do that, what you're going to do is that you want to do the bar chart. Are we together?
Yes, sir.
Click, remove that thing. Go first, go to your data. You want to do the bar chart separately. Another way of achieving this one also, go to bar chart, remove that group splitting, remove the splitting. We click on the split, Go back to the analyze all. So go back to that frequency. Yes, wait. There is something here where, unless if it's not there, oh, it's under. Click on that chart. Let me see. Click on the chart. Okay, let's click bar chart, but it's going to do it separately. Like there is under explore. We can. Okay, I know what to do. It's under. Wait. Click on. Okay, you have clicked bar chart. Okay, just click on statistics. Let me see what is there. Click on that statistics. Yeah, what I'm looking for. Yeah, it's not there. Okay, come out of the place. Continue. Or come out. Yeah. Click OK. It will still give you two batch about what I want to do. Click OK. It's okay. No, you have already done all this one now. Just click OK. Continue and OK. Hello? Hello? Is anybody hearing me? Is anybody hearing me? Hello? Hello? Okay, sorry. I was struggling with the network here. Now, let's see the result you have. Let's see the result you have. Which one is exit? Let's see the results. Eh? Do we have slow down? It's supposed to be batch as you are showing us now.
Oh, I thought you said we should change it back to pi. Okay.
Oh, no. Okay, don't worry. What I want to do, listen. Descriptive. No, you. Yeah, okay. Go to descriptive. And go to explore. No. Go back. Call back. I want you to go to explore. Explore. Analyze. Descriptive. Explore. No, where are you? It's showing us. Analyze, descriptive, explore. Yes. Yes. Move. Sex. Yeah. And wait, plot. Don't forget about, you cannot do statistics for sex. Plot. Okay. Because the explore is practically for what do I call it, for quantitative variable. Can you see all the things you are doing there is about come back of it, cancel it out, and put age there. Let's put age. Yes. Now put factor. Hope you have put factor. Put factor. Under factor, put the group. Click on the group. Go to plot. Anyway, by default, some of those things are there. And you see that immediately you put quantitative variable there, it's able to come up with this thing. But I click on that histogram also. We know that stem and leaf is one thing we do. Okay, continue. So click OK. So scroll down. If you look at it, even though you didn't split, if you remember, you didn't split. Did you split?
No.
But under the put factor, you put the group, it will split it. It's a factor, it will split it there. I don't know if you understand me.
I understand. This is another way of splitting.
Yeah, splitting, yes. It will split it there. And that one, let me go scroll down. I want to show you something. Scroll down. So it's version 20 you are using.
Yes, it's still version 20.
And those graph that are very funny graph. Anyway, scroll down to the last one. I want to see the box and whisker. That's what can you see now the box and whisker he put in the same place? Can you see?
Yes, for both groups.
If you split, if let's say you split, it will separate the box and whisker as you do it, though you didn't put factor there. It will do the box and whisker separately. If you want this box and whisker to be together, you know, normally when you are doing comparative study, all the graph you want to show, you want it to be side by side. They can see.
Yes.
This is for group 1, this is for group 2. So, this I don't know if you understand now.
Yes, thank you. Thank you.
I think this you didn't label the group because it's the initial one I've sent to you. When I sent it before, I didn't label it. That's why your own is showing group 1, group 2. It's supposed to give us urban and rural. So you have to go and examine now. You didn't label the group. So any question concerning the one we have done, hope we have not confused people. Any question? You can stop sharing now. Okay. You can stop sharing. Yes. Any question? Somebody said they don't know how to use the Excel. Jane.
Yes,
Jane.
sir.
So
Yes, sir.
Open your Excel and share.
Okay.
Let's do the graph.
Okay.
Want to do the graph?
Let me rename the file. Skin Legion, or which of them?
Just Skin Legion is this thing we are using. No, in fact, don't worry. I just open Excel. It's not just open it. I'm not saying you should share on the SPSS. Just share, open Excel, plain Excel, and share with us.
Okay.
That's what I say. Because Excel, the way you plot with it is you summarize. Because most of the time, what we plot with, you want to plot with it is pie chart and bar chart. Is the summary you just type inside the Excel.
Yeah.
So I may also show you how we still go back and do something. We'll do that one under correlation and regression, how you can plot it with even Excel. Because Excel is neater. It's neater than all these things.
Okay, so can you see my screen now?
Oh, it's Screen Legion you are giving us.
But I can create a new.
Use a new yes. Okay.
Okay, so.
Okay, why am I even wait? In fact, stop sharing. Stop sharing. Stop sharing, Jane.
Okay.
Dr. Aduse. Dr. Aduse. Dr. Aduse. Unmute yourself if you want to talk because I will not hear you unless you unmute yourself. We're not hearing you. Dr. Aduse.
Sir, I can hear you. My network is a bit poor.
Yes, I open Excel and share Excel with us. Open Excel and share with us.
I have not tried it.
Yes, now I want to tell you what to do. That's it. Open, you know how to click on Excel and open Excel now. Just open Excel and share with us. When you open Excel outside the Zoom, come to the Zoom and click on share screen and double click on that Excel. It will open to I will tell you what to do.
Sir, let me try. I'm having network issues. Let me just try.
Okay. Okay. We are not moving. Because if he cannot open it, because I think every other person know how to use the Excel to. That's why if he's the one that doesn't know how to use, I want her to share to that. Or is there another person that cannot use Excel to do the pie chart or bar chart? Is there another person that cannot use it? So that we skip that. Okay, so he's having network issue. Okay. Because if he's having network issue also, but okay, Jane, you can still open it. Oh, Jane, you can share it now. Let's do it. Jane, you can share it now. Let's do what we want to do. Yeah, okay. May is 44. May is 44. Type 44 for male. Jane. Jane. Are you there? Hello, Jane. Can anybody hear me? Can anybody hear me?
Yes, we can hear you, ma'am.
Okay, it looks like he froze.
Yes, I'm back. I don't know. And this thing was not like that before. I don't know. I'm in Akwanga, so this is just one remote place. Okay.
Okay, I've typed 44. What's female?
26. Okay. You plot it now. See the way he's doing it. Can you see? You see insert. You'll be talking now. If you are in demonstrating, be talking.
Okay, so now I want to plot this male and female using a pie chart. So if you
click on insert,
if you click on insert, it gives you different options, whether you want to do pivot table, recommended table, but what we're interested in is chart. And now we don't want bar chart, we don't want line chart.
Yeah.
What we want is a pie chart. So we'll go to this sign. This sign, you can see my cursor where we have a pie chart here. So if you click on the arrow pointing downwards, it gives you options to choose from. Yeah. So you have the 2D pie chart, which is here. You have the 3D, you have the donut. So depending on which one appeals to you, that's the one you will choose. So for me, most of the time I like to choose the donut.
Don't choose donut. Give the normal pie chart for us. Yes, great.
Okay, so once you choose it, it gives you see the legend, you see your male, you see your female. So if I want to add the numbers, like what he was trying to do with SPSS, all I need to do is to go to this plus sign. So once I click on the plus sign, it tells me already the title, the chat title is already activated. So all I need to do is just to double click on the chat title, and then I add the title to this chat. Now,
if you don't want also, if you don't want, because sometimes me, I don't like the title there, because I will write the title on that. You can uncheck it. It will remove the title.
Yeah.
If you don't want the title, okay? Go on. Yes.
Then, so now what we want to do is to label. So once you select data label, automatically imputes the figures that corresponds to the different sexes. So that's it.
Yeah. Let's still go back to that plus where you are doing something. That's some other thing I want. Give to that.
Okay.
Yes. Click on that plus. Now, you know, this one is pie chart. We want to label the male, female inside the chart. We don't want it to be out. So since it's not, we don't need since it's one group, we don't need legend. Yeah. We don't want the legend. We want to put the male inside as part of the something and female. So legend is more important when you are having two groups you are representing so that you can separate them. But this one, the color has already separated the male and female for us, and we can actually type. So my internet is just coming again. So if you don't want the legend, you uncheck the legend also. Uncheck the legend. If you still come to the label, under the label, if you still click, there's arrow in front of the label. You go there. The label itself, the arrow, it gives you option. Click on it. Can you see? You want to this option now. It say we want to look at the writing. 26. You want it at the center or the. But that's not the issue now. You want more option because I want to be able to type the male and female inside it. So you click on more option. Click on the more option. It's as if it has gone, but go back to that plus.
It's coming.
It's coming. Go back to that plus.
Okay, okay.
Sometimes it's on the side. It's on the side, right? It's on the side. Can you see on the side? It's on the right side of the graph. It's on the right side of the page. Look at it. The options. Jane, are you with me? Can anybody hear me? Hello? Hello? Hello?
Yes, hello, I can hear you.
I was not hearing again. Okay. My internet has started again.
Okay, so I'm on the options.
Yes, you're on the options. Okay. Coming. I'm trying to, okay.
Serious name category.
I'm not saying you are, the screen isn't mean that I make it small like that. I can't see. Your screen is small. Okay, I've seen it.
Okay.
I've seen it, don't worry. I've seen it, it has come up. So the options now, they are there. Come to the far left, right. You see percentage, category name. Click on category name on the far right side of the page. Hello? Hello?
Hello?
Yes, can you hear me?
Yes, I can hear you. I have clicked on category name.
If you look at it, immediately it has written male, female in front of them. It has written it in front of them, male, female.
Yes.
You want percentage. No, you have, yes, percentage. So can you see now? So you can now go back here, you have separated them, which is okay. Some people can leave it like this. So male is 26, female is 26, 37%, male is 44,
63%.
Exactly. Okay, go to another page. Let's try to see how we plot pie chart, and we can plot for two groups. Just give some arbitrary value. Just to do that, when we do the pie chart, so we just stop that one. We'll do some other things. Okay. Yeah, and the next. Okay, now, yes. In this case now, I want you to. I want us to use. We want to plot pie chart. Let's plot it for urban rural. Don't insert yet. Want to do it for urban rural. So in front, the cell above the 50, above the 56, put urban there.
Okay.
The next cell, put rural. And I put another value also, and both of them should add up to the total for this one, because what I'm seeing 79 as the total. So if you put 57, that won't be 28 now. Put 28. Put 28 where you are. The way you are drawing pie chart, to be sincere with you, is the percentage you want to put there. You don't want to put the, if you see this one, you put the real value. But we have a way of getting the percentage. But this one, we want to put a percentage. Let's put percentage here instead of this thing. So let both of them, let's assume it's percentage. Let both of them add up to 100. And this one is 56 one. Let this one be 44 and 34. 56 female should be 34 for the urban. Male 56, female 34 for the urban. For the urban. For the urban, let the female be 34. In that case, no, you are not. You are in rural now. Addition, the total, the percentage for, yes, urban should be 100. Yes, I'm since, yes, put 34 there now. And this one will be 49.
No, that's 90. It's 90.
It should be 44.
It's 100.
44.
44.
Oh, it's 44. Okay, it's 44. Sorry. Yes. This one should be 49. Because if it is pie chart, is their percentage you are bringing out. If it is their percentage, even if it is even, it may not even be female, it can be the age group, whatever you want to plot. But of course, you want the percentage should be added to 100. So there are two now. So you got to select them together now. Select them, yes. Yes. Now go and insert. So we want to do bar chart. Bar, not pie, no bar chart. Yes. Yes. Can we see now? So you can now start doing all those other things. And you see, and that is where your legend work, because you actually need the legend here, because you have male and female. You also have urban and rural. In that case, you need the legend. The legend, but the legend is showing, that's not what we want to show. Yes, I'm now. Can you see now? Because look at this. What we want to show male and female, and this place should be the location. Though, whichever way you can do it, in this case now, it's time to compare in urban, male and female, in rural, male and female. Yeah, okay, I think it's okay like that. It's okay like that. If you want to change the pattern, because the other pattern may make more sense, go to, there's format, under the format, you can just see switch row and column. Click on it, you see what will happen. But we are coming back to this one, this is what we are plotting. Let's click on that switch row and column. Can you see? No, you have not clicked on it. Switch row and column. I was seeing it now. You click on another thing.
Okay.
There's one arrow that up and down like that. No, it's under the. No, don't click on format. It's not. I was seeing it. Okay, come back here. Come back to what you are doing then. So the legend, go to the side and that arrow and that plus and label them. Click on it, yes. Now you can move legend to the top. No, sometimes if you don't want, you can leave it there, but if you want it at the side at the top, you can relocate the legend. Under the legend, I usually put it at the top. No, yes. If you want to put it at, you just click, no, you click on the legend, you don't, well, you can drag it, okay, that's great. You can drag it, then you can, option is there, location of the legend at the top. Yeah, that's great. Now, you know pie chart now, like bar chart on like pie chart, it will give you axis. How do you label the axis? So if you want to label the axis now, you see, go back to that your plus sign, you see axis label, axis title. Click on axis title, the axis title number 2, yes. Immediately, it will now give you axis title there. You can now change this one to location. So actually, what you want to do is still come back to what I was saying. Yeah, I don't know why that thing. I want it to be sex. So the location will be because what we're actually showing, what is showing now is showing that you are showing location between male and female. No, you want to show sex between urban and rural. So that is where I want you to come to this around the format. There is one arrow. Change column, change row and column. I was seeing it. I don't know. I don't know why you're this. Yes. Come out of the. It's like you click on design or what? Click on format. No. Up, and your.
Okay.
Click on format. Is it format? Okay. Click on design. It should be on design. Click on design. Click on design. Is beside it. It's beside the format.
Beside it, okay, design, okay.
Yes. Yeah, look at that thing. It's you that went to
format. Okay, this one.
Yes,
okay.
Click on it now. Click on it. Can you see now? It has changed it for you. So you see male and female, urban and rural. Can you see?
Yes.
Can you see now? So what you are, so in our title here now will be sex. It's sex you want to show. So but you put the male, compare the urban and rural, then the female compare urban and rural. You see it now, and the legend will change to urban and rural. So now, if you want to, then you want to location the title, change the title now, the axis title, type sex or gender. Sex. The gender, I don't like using that gender because it's a social role. Then the social role. Then the other one percentage, the vertical axis. No, go to the vertical axis. Location, yes. Oh, you have already, is percentage. It's not location, it's percentage. But what you are showing there is the percentage, the graph. The value there is in percentage. Yes. Great. Yes. So sometimes also you can go to the area of plus sign. You may want to remove the grid line. Yes, you want to remove the grid line. Yes, click on that plus something. Okay, you have removed the grid line. And you have removed it.
I click on the line, he highlighted it, and then I deleted.
You can delete it here. Or here you can remove it. Sometimes you can say leave the vertical, leave the horizontal, you know. Then there's something, many people, because we measure this in percentage. If you look at it, the height of the graph, the calibration will just be above the highest value. The highest value we have is 56. That's the calibration here is 60. If you want to change it to percentage, you want it to be 100% because 100% is the scale. Double click on that axis where your arrow is, just double click. Where exactly? Right click on it now. Right click on it. Let's see. You see format axis, the last option. Click on the last option, format axis. Immediately you do that, you come to the right side of your page. You see maximum is 60. Can you see? Change it to 100. Change the maximum to 100. That maximum that is 60, change it to 100. Can you hear me? Yeah, the network has started. Can you hear me? Hello? Hello?
Hello, I can hear you. I can hear you, sir.
So you have changed here. Immediately you change to 100, you have now. Can you see? It has brought the scale to 100. So I think that's all. Then another thing, some people they don't want, because if you bring this graph out now, it has outline. Some people don't want, if you go and paste it now, it will have outline like a block. If you don't want the outline, just right click on the space around the graph. Right click on the space around the graph. Not inside on the graph. Yes, right click now. Right click. You know, outside, yes. Can you see outline? I don't want the one inside, you are right clicking on the one inside. The one outside because that one is showing. Move your cursor out small. Yes, right click. Yes. You see outline. Click on that outline. That blue something. That blue outline. Yeah, exactly. Yes, click on the outline. Now click no outline. Come and see. No outline. Great. It has removed the outline. Remove your cursor, you see. Yeah, can you see? If you go and click, paste it now, it will not put outline there. Because many times, it depends on, especially if for academics, something, they don't want the outline. So those are the many things you can do. You can change the color of the background. If it were to be development work we are doing now, you like the color. You even click and go and under format and put color back, correct background. But if it is academic, they want it plain. So I think we are, let's just stop. Any question concerning this one? This one is extracurricular something. You can stop sharing. Thank you. Yeah, stop sharing. Any question?
Just a quick question. Is this the best way to present this that chart comparing sex distribution of urban and rural dwellers.
Yeah,
That kind of, is
yeah,
that the best way?
yeah, it's better because it doesn't make sense for you. Okay, you want to present categorical variable, right? And you now have two group or three group is comparative. Will you go and have each graph for each group? You cannot. So it's better you have the graph together. The legend is what we separate them. After all, it's comparative.
No, I agree that it should be like this. I'm just saying, you know, we had to eventually switch the axis where we now put initially it was
okay.
Yes. That was coming our
Yes. Okay. Let me tell you. Let me just say something. Normally, if let's say you want to plot that graph, you know, different way. When Jane was typing it, right? Jane typed male, female like this, and now put the horizontal, the value horizontal wide. Some people also can do it the other way. Doesn't really matter. But it's you that know what you want to present. As you do it, it gives you the first option. That first option, what it's telling us is if you are to label, what will you put down? You label location. It's location that is put it down. It makes it location. The legend is male, female. That one is telling you is location distribution by sex. I don't know if you understand me now. So, but what you want to present is sex by location. So all you just need to do is just click. They have made the provision for you to switch. So if you look at the computer cannot think for you, you are the one that is doing the thinking, but they give you the option what you want. It looks like a marketplace, what you want. But you may not know the right thing. If you don't know the right thing, you ask for the wrong thing. And you can get to a place where they say,
so it's sex distribution by location, not location distribution by sex.
Exactly. Because it's giving us, it's putting, what if you do that, what you are now showing is that what it will show you, what you are showing is the percentage of the location by sex. Whereas you are putting in the percentage of sex by location. Are you following?
Yes, I am.
That's great.
Thank you.
So any other one? So I want us to see maybe from what let me quickly show because we still have some time, there are some things you want to know outside because like we were able to move fast and cover a lot of ground. Let me just show you what we plan to do if you still have question in any area. But if we have time, I just want us to maybe see how do you do the correlation because I can see that this BMI data, a lot of quantitative variable there. I just run correlation, then you can scattergram, how you do it, and finest scattergram, I do it with Excel. Plot this, bring the whole data set of that variable. I just put them in Excel and now do find scattergram and show the R square. Though is actually outside what we are doing. But let's first of all go through. It's good to be sure that everybody understand what we plan to understand first before you be doing extracurricular, because that extracurricular will raise a lot of questions because we have training for all of them. So I like it when you take it bit by bit, you understand it. Now, exploring the key windows in SPSS, is anybody having issue with that? No, is there anybody? No, we still have 30 minutes. Is there anybody having issue with exploring key window to know the function?
No.
Yes?
No.
Okay. Defining variables and entering data with SPSS and Excel. No, that's one of the things we wanted to do. Anybody have issue with that? If you have issue, we'll go and revisit it because don't just hide. If you have issue, let us know. Defining variable. Somebody's machine is echoing my voice. It's Jane's machine. Hello? Can you see now? So Defining variables and entering data with SPSS, no problem. What of converting data in Excel to SPSS? Can everybody do that? Are you sure that somebody that is, the computer has not been working can do it? Because until you do it, you don't know if you can do it. Hello? Are you people hearing me? If you hear me, say hi. Unmute yourself and talk if you hear me. If you are hearing me. Hello? Can you hear me? Can you hear me?
Yes.
Hello?
I hear you now.
Yeah. It was hanging. So what I was saying, please, I said converting data in Excel to SPSS. Everybody can do that. If you cannot do that, let me know. Then screening and cleaning data, the way we screen and clean our data, both in Excel and SPSS. Nobody is answering me. Hello?
This one, I don't know this one, sir. Screening data in SPSS. I don't know this one, sir.
Okay, that's fine. Let me know that. Okay, number 4. Okay, sorting data file. Sorting data file. Everybody knows this one, right? You can sort.
I can sort in Excel, but I can't sort in SPSS.
And the funniest thing is even the SPSS is simpler. Okay, no problem. Sorting. Descriptive, okay, these are all those things. That one, when you say descriptive, is a big thing. Then collapsing continuous variable. Everybody can do that. That's what we have done up to 5 times. When we range, where we go to transform the code to different variables. Yes, into like what we did for age, that we've now said less than 20 to 29, 30, 39. So everybody can do that. And we also did it for BMI. We also did it for blood pressure, systolic blood pressure. So everybody can do that. Or less, let me know. Splitting data file. That one is in file. You can even see that we have 3 methods of splitting the data file. Or demonstrated 3 ways of splitting data file. So everybody can split. You go to data, select cases, you remove all cases, and put if condition. No, it's not if condition. You put group, compare group, you click. You move the group variable there. Okay. What of exploring data for normality? To explore data for normality of distribution. We did that yesterday. So does anybody have issue with that? That's what the histogram, Dr. Taiwo. Dr. Taiwo, are you talking to us?
No, sir. No, sir.
Okay. If you know that you want to talk to somebody in you mute yourself. Okay. Transforming data set. Transforming data set. No, we did a log transformation. We did it. If you don't have a problem with that, okay. Computing new variable from existing one. All we did for like a BMI is a new variable. So do you have a problem with that? Then using Boolean logic to select cases and create new variable. That was what we did for systolic and diastolic blood pressure to bring out hypertensive. Does anybody have a problem with that? So everybody seems to get it right.
Yes, I think we can repeat this last one.
Boolean logic, okay?
Yes.
So maybe the word bullying, that is, I want to bully us, it's not possible. Don't worry. Maybe I'll first form. Okay. Okay. The one gene we say number, that's screening and sorting. Okay. You quickly do that, and I'll also show you something. Okay, let me just go to my own. Let me open my own. Let me open the file. Don't let me call anybody now. Because when it is close to the end, that people are tired. They don't want to record to do anything. Just 1 minute. Let me bring my file out. So this is the skin lesion data file. So Jane, you said the sorting. Are you listening now? Jane, please, if you want to talk to me, you have to unmute yourself so that I know that you are hearing me. Jane, is it there? Hello? Is anybody hearing me? Hello? Sorry. So, Jane, are you there?
I am here, sir. I am here.
So if you want to sort, very simple. You just the variable you want to sort with, you just click on the title in the data editor window on the data view. Like my task, if I want to sort based on my task status now, I'll just right click. You see sort ascending or sort descending.
Oh.
If it is sort
Okay.
ascending, if it is number I put there, it is sort from smallest to the highest. If it is descending, it is sort from highest to the smallest. If it is not number we enter there, if it is letter, it is sort from, if you say ascending, from A to Z. If it is, if it is descending from the highest, the most remote letter, you start from there. And if there's anyone that is empty, if you say ascending, the empty space is what I call first. If it is sort descending, the empty spaces will come last. You get it now? And if, okay, let's just say, like my task says sort ascending. Can you see now? Put all the one first. Can you see? 1, 2.
Yes.
Yes. But of course, once you sort by any variable apart from the serial number, it will scatter the serial number also. Yes, I mean now. You have to be careful. In some situation, you are working with data and not discover that someone many times after I've analyzed, some people they send their data in Excel to me. After you analyze, you are doing that. Now, oh, I made mistake in one variable. It's not like that. I'll re-enter it. I'll just go and cook something. And you say, yeah, it's actually delete and I've entered it. Just say you. So in that case, I cannot go and import the Excel because of few changes they make. After all, I've already cleaned the data. I've already done some, and I even created new variable. I got this age group, all those things, group. Some of those things you have defined a lot of things in the data set is already bulky. So you cannot start to do that. What you're going to do is to go and pick that column for that variable here, the person has changed, and come and paste. But in doing that, you have to be careful. You have to make sure that that is why when they give you a data set also, make sure that it's sorted on the Excel very well. If they have not sorted it, if some people don't sort, they don't even put serial number or sort. I will put serial number and sort and make sure that it's along the serial number even before I import it to SPSS. If I do that also, the serial number is there. So in that case, because as you are working, try to sort to clean, you discover that once you sort by some other thing apart from serial number, it has scattered the serial, the arrangement. So if they are now bringing something, if you forget, you just go and copy and paste, you have messed up the whole thing, because once you copy, the value you copy for a particular set may not be the value for that person. For another way, you have scattered it. So you have to go back, first of all, sort according to your serial number, ascending according to your serial number, and make sure so that in that Excel is sorted, you now pick, you know that number 1 is what you are bringing to number 1, number 10 is what you are bringing to number 10. Now come back, paste on it. I think it's very clear now. So this way out, you can sort by any of them, any of the value. Most of the time, the reason we sort, why? If you like when you saw outlier, you can quickly sort instead of you to be looking for this. So there's a value that the age of children you are seeing 70 years, or age of adult you are seeing 7. You know that there's a problem. Once you just sort, you'll be able to locate the number and you relate it to the serial number and go to your questionnaire to see, pick the questionnaire to see what is the actual value of that thing. That's the essence of sorting. It's very if you do all those rudimentary things, you can mess up the whole project. Because if you mess it up, you just scatter. The result may not come out as something. In fact, it's not the right result. You can just say that you can't even know what is happening to the project. Because it doesn't make meaning. The result it don't even tally with knowledge, with anything that is existing. And it's because of this management of this thing. Now, that's sorting. I think the second thing you talk about is okay, before the sorting, something you first of all talk about. Sorting is just the second one. I thought I remember it. Screening, cleaning data. Okay, they are related. So the cleaning of data, they are related. Cleaning and sorting, they are related. So what do you mean by cleaning data? It's part of it. In fact, cleaning and sorting, they are related. So it can start, if you import SPSS now, you may see that it's possible you enter it not in number, which actually to me is better. You make less mistake if you're entering with Excel. If it is quantitative variable, they put it. If you quantitative, you just type that thing, male, female, all those things, just type it there. Then when they bring it, we sort. When I will sort, and I say yes mean 1, no mean 2. Once I sort, you don't need to be, it's not that you'll be picking it, yes, I'll be putting 2. No. You just sort. Once you sort, it will put all the years together, put all the notes together, just put 1 and copy, I just run down one my paste. The other one for the note. I've done it. I'm going to label it. So sorting and cleaning, they go together. Sorting and cleaning. So when even cleaning also still go, when you have done that initial thing, you run your frequency to see the way it is. When you run the frequency for all of them, that's where you begin to go through the result one by one to see. You see empty spaces. You also see some normal, abnormal value. Like male, female now, you enter 1, 2, you can see 3. So that may make mistake by entering, maybe you want to type 1 or 2, whatever. So you have to make the correction. You see some value outside the range of the something. And even if it is, even the SPSS where they have coded, if the person enters in SPSS, where he has coded the thing, male, female is here. But they can still go and enter 5. And that one will stand out. When you run it, the number of male will come out. That one that is figure 5 will come out separately. It's not under anything. So you have to begin to find out which one. So you have to find out. So some of the time you have to call the person, check number so and so. What is the says? Sometimes if it is a true few occasion, maybe only 1 says that is missing. And if the majority, like this case of sin lesion now, the majority are female. If one is missing, I just look at some other social demographics. The probability that that person is female is higher than now because the majority are female. So you can just put 1. If it is only 1, just put 1 set there. If it is age, that one is even easier because you can just run the median and look at. You can decide to use me, you can decide to use median depending to now replace. Because that one will not change the whole result. They help you to palliate that thing. So if there are 2 groups, maybe you sort also by the group so that because the one group may be different from the other group. So if you are replacing, try to clean, replace some age, 1 or 2 ages of some people. You make sure that you use the average, you calculate the separate median and mean for both of them. So the one that are coming from this, you use the median to replace. The one that come from the other side, you use the median or other side to replace it, so that you don't just treat it as one global data. Those are the things. So sorting also, apart from having the skill of the computer, you have to think very well in sorting and in cleaning your data. Jane, is it okay? Are you okay with that? Are you okay with
Yes,
that?
sir.
Okay,
I'm okay, sir. Very clear, sir. I now understand. Thank you very much.
Okay.
And sorry for taking you back.
No problem. I'm sure some other people gain something from that. I want to show us something before concerning that Boolean logic. You know, the slide we used during our presentation on probability and normal distribution. We talk much about that Boolean logic, so that let me quickly go there before now come to now finish it up. So the probability and normal distribution. Sorry, the network was just taking me. Yeah. Yes. I think it was the, yeah, I think it's, no, not this one. So let me quickly show you, because this has reached the end, control end, because it seems too close to the end. Yes. Okay, send of probability. Yes, I think we have. Yes, can you see the slide? Can we see the slide?
Yes.
Yes. So the Boolean logic,
yes, we can.
Yes, has something to do with probability rule. It's only two rules we are just going to do. There are many rules there. It's only two rules that is applicable here. The addition rule and the multiplication rule. The addition rule for individual outcome, the probability of an event is the sum of the probability of all the individual outcome of that event. That is, look at it. If you have, it's better you even look at it pictorially, because sometimes I don't like talking to the ear. Addition rule. Look at this picture now. Looking at addition rule. We have two types of the addition rule. One is applicable to mutually exclusive events. Another one is applicable to non-mutually exclusive events. So mutually exclusive event, two events are said to be mutually exclusive if, can you see? If you belong to one group, you cannot belong to the other group. Look at this first diagram. If somebody is in A and another person, you cannot be in A and be in B because there is no overlap. You cannot be a male and a female. That's what it means. So, like when you do, most of your questions that add up to 100 is mutually exclusive. But the one you say, tick as many as possible, they are independent, they are not mutually exclusive. They say, okay, your child, does he have diarrhea? Does he have vomiting? No diarrhea and vomiting. There can be, so a child can have diarrhea and vomiting. Can have only vomiting. You can only, so for the fact that a child have diarrhea doesn't mean that the child will not have vomiting. So having diarrhea and vomiting, they are not mutually exclusive. But for a child to be a male and female is mutually exclusive. Your child cannot be a male and his sister as a female. So that is why if it says now male, female, there's no overlap. But if it is diarrhea and vomiting, there will be overlap. So there will be people that have diarrhea alone, will be in this white here. The people that have vomiting alone will be here. The people that have both diarrhea and vomiting will be in the overlap. Can you see? So this is the first group are mutually exclusive. The second one are non-mutually exclusive. Now the addition rule, how do you add? That is the addition. That is probability of A plus probability of B. That is the addition. So the addition works differently. For this one that is mutually exclusive, probability of either A or B just mean that A plus B. You know, if you say that probability that the person is either a male or female, is the probability that it's a male plus the probability of the female. If the percentage of the male is 45, of course the probability of the female is 55. So you add it together to complete the probability. That is mutually exclusive. The non-mutually exclusive is not straightforward like that. If a child have vomiting, then some children have vomiting, some have diarrhea, and we have some people that have both of them. So the probability of vomiting plus probability of diarrhea, you cannot just add the two. If you add the two, there will be some people that are counted double. I don't know if you understand me. If we have 30 children and 25 have diarrhea and 15 have vomited, it is obvious. If you have 25 and 15, it gives you 40. It shows that, and the total is 30. It shows that there are 10 that overlap. That shows that there are 10 of the children that have both diarrhea and vomiting. So the probability of having diarrhea will be 25 over 30. Probability of vomiting 50 over 30. But if you add the two percentage together, it will be more than 100%. So that shows that the overlap, the people that overlap, you have counted them under diarrhea, also count them the same way under vomiting. So the best way is to remove one out of the counting, and that is the logic here. Look at it. Probability of A or B, if it's not mutually exclusive, if you want to add them together. Are you listening? Are you hearing me, please? I want to be sure that my network has not gone. Hello? Can you hear me?
I can hear you. I can hear you, sir.
Yes.
I can hear you, sir.
Probability of A plus B, which diarrhea plus vomit or vomiting now will be probability of diarrhea plus probability of vomiting minus probability of diarrhea and vomiting. Can you see? Diarrhea and vomiting are the people that have both diarrhea and vomiting. You know, in that case, you have already counted, you counted them under A, you counted them under B, you have counted them 2 times. You now remove one. So that is why the addition rule is probability of A plus probability of B and minus probability of A and B. A and B mean at the same time concurrently. Does it make sense? So we don't even need to even go further. You have got the logic now. The logic is that if you want to know, you want to gather as many people, okay, I want to know all the people that have diarrhea and vomiting. In that case, it may be only diarrhea alone, it may be diarrhea and vomiting together, it may be vomiting. I just want them. That is the addition rule. Just apply. So that's something that is not mutually exclusive. So now, though it's the same, even the same rule applies to mutually exclusive. The only thing is that this diarrhea, the nearest one minus will be 0 here because there's no overlap. That's why it doesn't happen. The addition rule is this probability A or B is probability A plus probability B minus probability A and B. But for mutually exclusive, there's nothing like A and B. There's no overlap. So that A and B is 0. So that is why it's out of the formula. Now, the multiplication, if you look at it also, look at the diagram of this probability A. Can you see? You know, it's something that overlaps. Probability A is this yellow. Then probability B is this gray blue. Then the addition of the minus A and B is where what is common to them. So the addition rule now will now be this plus this, you know, is the OA here now and the OB here. You now remove the overlap because this overlap, this one contribute, this one contribute. There are 2 of them. So you now remove one. That's all. That is the addition rule. So the multiplication rule, that one is very, even from what we have already done, you can get it. A and B mean probability. Okay. The multiplication rule, the conditional, okay, multiplication rule. Okay, I didn't show it there. But if it is for probability of simultaneous occurrence of two events, we have already said it. Two events that occur at the same time. So you're like the people, if you say probability of diarrhea and vomiting, it is only those children that have both that you select out. Diarrhea and vomiting. If it's only diarrhea, it's not eligible. If it's only vomiting, that should be diarrhea and vomiting. That's addition rule. So we go to be A times probabilities A times probability B. That's the multiplication rule. If the probability of simultaneous occurrence of the event is if A and B are two independent events. Independent means that one does not preclude the other from happening. Anyone can happen at the same time. So probability A and B will be probability A times probability B. Now they just give example here. Just give that one. Let's just go to the Boolean logic. I explained it there. That's the way. This is probability rule and Boolean logic. Look at our example here. The Boolean logic use and or not Boolean operators. But the funniest thing is that even before the advancement in probability, this German man, the Boolean, explained this thing long ago. You know, there are some people that are just very intelligent and and look at, for example, if you want to search in search engine now, you want to search for literature, you are looking for obesity and diabetes. So what it means that it's only a paper that has both obesity and diabetes. So that is the overlap you are looking for. This one outside this overlap, obesity, that's obesity low. You are not interested. Sorry though. So can you hear now? So this other one, diabetes alone, you are not interested. But you are interested in obesity. What's wrong with this? Sorry. You are interested in obesity and diabetes. So it will narrow your selection. It's only the few one that has both obesity and diabetes in the journal that it will select for you. That's, you see. So that is, and then if it is all obesity or diabetes, so you are having 3 groups of people coming to you. Those people that have obesity alone, they are qualified. Those people that have diabetes alone, they are qualified. Both the people that have both obesity and diabetes, they are qualified. So that is all. This other one is just not teenagers, not okay. The example they even use for all years, geriatric or elderly. No, elderly. You know, sometimes it makes sense if you are looking for, you are searching literature for geriatric. Are you following? Can you hear me? Hello? Can you hear?
Yes, sir.
Yeah, yes,
Yes,
we can hear
You
you.
are checking
Yes,
literature.
sir.
Yeah, you are checking literature for elderly, because if elderly put elderly there is correct. Geriatric is correct. You cannot say, if you say elderly, you are wasting your time, because they can instead of geriatric. If they say, some people use language geriatric, so if you want to cite, it's better to say geriatric or elderly. So it will help you to capture all the people that they are treating. There is all the literature that is about elderly, because it's either they either call it geriatric or elderly. Not teenager, not adolescent. You know, there are some situations you want, it's teenager you're looking at, you don't want adolescent. You know that the teenagers are looking for teenagers. So in that Dr. Taiwo.
Sorry.
No, if we are doing it sort of you to, okay. that is the logic. So I also talk about you using for analysis. This is where we are even in now. I give an example here. Look at the systolic hypertension, diastolic hypertension. Can you see? We have people. This is the total people. The people that are, if you had everything together, 310 plus all this one, they are in the data set bed. 21 have systolic hypertension, 7 have diastolic hypertension. Out of the 21 and the 7 that have 2 are both. Can you see now? There's overlap in 2. That shows that the people that have systolic hypertension alone out of 21 is 19. The people that have diastolic hypertension alone out of 21 is 5. The 2 are both. The same thing, this is a study on adolescent, verbal harassment, breast caressing, unwelcome kissing, some experiences, some adolescent experience. So can you see? This is an example of 3. If let's say we have data on history of hypertension, it makes 3 to be this as an example of 2, but it will have been 3 here. If we have the history of hypertension also. Then look at this one that have 3. You can see 39. If you want to know how many people have verbal harassment, you have to write 39 plus 8 plus 80 plus 31. That would be people that have verbal harassment. If you want to talk about the people that have breast caressing, you have to talk about 19, 8, 18, 40. The people that have unwelcome kissing will be 40, 40, 18, 31. What is there is that this 18 in the middle is the one that have all the 3. These 14 have both breast caressing and unwelcome kissing. These 8 have both breast caressing and verbal harassment. These 31 have both verbal harassment and unwelcome kissing. Does it make sense now? So that is way. So when there are 3 things that define something, like for example now, the example of hypertension. If you are doing a study, you want to know prevalence of hypertension, you cannot get it. You can, unless if you don't analyze it or give it to anybody that analyze it, you will not get the right value for yourself, because there are 3 things that define it. Or at most, if they didn't get the history, at least the 2 measurements, the systolic and diastolic. If there is history of hypertension, it's part of it also. So that was what I was trying to explain there. And it's very simple. Let me just go back to the data set. Okay, the data set I use. Okay, let me go and read that, open that PMI something. But that is the one that, yes. I don't know if you can see the PMI data now. Can you see the BMI data? Can see the BMI data I just share now. So what I did, okay, we can even talk about, okay, let's look at, I don't know if I have defined obesity in my own here. BMI, okay. I didn't define BMI here. Okay. Okay. Let me quickly define BMI the way we did the other time, and I'll use it. Let's look for people that have the systolic hypertension, and obesity, maybe something greater than 30 or more. Let's look at it and use that Boolean logic. Can you hear me, please? Somebody just tell me you can hear me. Somebody, one person should tell me that you can hear me.
Yes, we can hear you.
That's great. So let's look at the way we compute BMI the other time. Remember the revision. Transform, click on compute. That's a BMI. That is the target variable. And it's not say is equal to what? Now say weight divided by is here. Now put this bracket because you are dividing by two things. Both of them will be division. So height multiply, this asterisk is multiplied by height. Go back to height again. That is it. You are define your BMI. And it's defined. If I share the data editor window, you see it. You see it's defined at the extreme end here. Can you see BMI? You can see it there at the extreme end, right side. That's the BMI. Now, let's select people that have systolic hypertension greater than or equal to 140, diastolic greater than or equal to 19, and BMI greater than or equal to 30. So in that case, all you just need to do is say data, select cases, select cases. No, by default is all cases. You click on if condition is satisfied. Immediately you do that. You know the if will be highlighted. Now click if. Now say okay, systolic BP greater than or equal to 140, or can you see the logic now? Boolean logic, that additional rule. Or I'm not looking for people that have, if let's say I'm looking for people that have systolic hypertension, at the same time those people have diastolic hypertension, and at the same time those people have obesity greater than 30, I will use and. Of course, it will not even exist, or there will be few that will have all the three conditions. But if it is all, there will be plenty, because it's what you are saying, telling us if it's all, at least one of them. So or no, or diastolic blood pressure greater than or equal to 19, or BMI greater than or equal to 30. Can you see? So the thing it will show us in data editor window. Can you see? Can you see the filter at the extreme end here? Can you see the filter? So if you look at the left side of the bar here, you see it mark them out somehow. The one you cross are the one that didn't satisfy the condition. The one that satisfies the condition, he marked them 1-1, but it didn't cross them here. The one that he crossed out here, he marked them 0-0 under filter. He's telling you that all the one that meet this condition, he mark them 1. All the one that didn't meet the mark them 1 and call it selected. The view that didn't meet the condition, you mark them 0 and call it not selected. So you see that under variable view filter. Can you see? Can you see? If you come here under this selected, not selected. The selected are the one that meet the condition. The not selected are the one that meet. So if you want to say, if you want to now mark it now, say systolic hypertension with obesity. You know, there are two reasons for doing this type of thing. You may do it, I just want to select them alone to now run some analysis. With that now, I can go and be running some analysis. Only those ones that will come out. The total will be for those ones. Any analysis I want to run. That's one way of doing it. But it may not be only for that one. It may even be, I even want to know them to define. I don't know what they call this type of people. I don't know. But most of the time you can select them for that. If let's say the third conditioner is history of hypertension, and that's okay. These are the hypertensive people. Does it make sense? Any question concerning that? I want to do another one that you make use of hand. This one just make use of or. This is additional rule. But I want to use this the one that you make use of hand. I want a question. Yes. Any question? Any question? The internet is unstable again. Can anybody hear me?
Yes, sir. Thank you very much, sir.
Any question concerning
You
this
really
one?
did it. You explained it very well,
Yes,
sir.
thank you.
That shows that we can go and do it, right? So let's do the second one.
Yes.
Let's do the
Okay.
second one. We are not looking for people that have two condition, the condition and fulfill. Let's say this person, even it can even be okay. Let's use the same condition, it will be hand. But let me even yes, let me label this one so that because if you don't label it now, you don't choose that. If you put another something, it will replace that filter. You will now have the history of that one. Do you get it now? So you will not have the history unless you label it. Let me label it. So let's label it. Let's call it hypertension, obesity. I don't even know what hypertensive and or obese. Yes, hypertensive or obese. You know that's what it means now. It's any of the or. So you can easily say this one is yes. This one is no. Now, we want to go to the next one. Now, data again, select cases, the conditions are already there. Even the way, you know, because it's the same thing, you know, I can go and just replace this all with and. Can you see? It has, you know, I type the all by the hand. It has this sign here, you can use it. Can you see? Just replace it with and. Okay. So we are looking for people that have all the conditions. There will be fewer. Let me show you the data editor window now. You will see that there are fewer. You know, by the time you can you see? If you look at it, cancel almost everything. Yes, I mean, in fact, it's like it's only one self that is one or two. Let's see. We're going to run them now. Let me label it also. This is hypertensive and obese. The first one is hypertensive or obese. This one is hypertensive and obese. So, you know, the yes or no also, I want to put it there. I'll just copy this, right click, copy, and paste here. So instead of typing it's there. So one is that hypertensive or obese, one is hypertensive and obese. So I want to run it down. If I want to run, I have to go back to data and no, I've already labeled it. All cases. All cases. I don't know. Okay. Let me. So let's analyze descriptive frequency. I just move both of them in to see what they will offer. This is the second one. I don't know why it came. So let me share the result. Can you see? Though I didn't split the file, I just analyze just for you to see. Can you see now? Can you see the result? For the first one, we have 25 that satisfy all the conditions. Hypertensive, obese, hypertensive, obese, and obese, or obese, any of the 25 of them. But for the one that is hypertensive or an obese, it's only one person. The only one person that have the two, in fact, have both systolic, diastolic hypertension, and obese. Can you see? They have all the three conditions: systolic, diastolic, and obesity. one person. But the person that has any of the, at least one, is 25. If you want to know the way this thing now work now, we can, the only thing we have not done is to even define the obesity and hypertension separately. If you define it separately, you'll be able to know, okay, maybe I should do that now. Let me do that. Or do you have question in the one I've just done? Let me just do that. Let's define, we define it together. Let's even separate, let's say, okay, who are these people that are hypertensive? Let's even know systolic hypertension. Let's know. So it's the same, we just say select cases. If condition is met, this one now we are looking for systolic hypertension alone. That will be the first one. You see, systolic hypertension, click. So if you go to the data editor window, you cannot define all of them at the same and say you are going by. You have to, as you define it, you go to variable view and change, because if you go and do another one, it will replace this one. So I'll just say systolic hypertension. No, I will not, because I put gap. Systolic hypertension. The other one, that's systolic hypertension. Let's do it. So here, I can just replace, since it's not even the same thing. I will now move that systolic BP greater than or equal to 19. Okay. So I go back to data editor window, variable view, and say diastolic hypertension. Last one, I go to the same place, and now what I want now is BMI greater than or equal to 30. And say obesity. Let me go to data editor window, and I say obesity. Obesity. So I can just say, because it's the same yes or no to use. Just copy this one, just select all, paste. If you look at it now, they are all nominal because they are two category. Yes, no, yes, no. They are no. If let's say is we divide into 3 or 4 categories, each of them, then that's what you'll be talking of. Is he ordinary or whatever? Now, I want to now go and run it, but I have to first of all say select all cases. After doing that, I will go and run. Okay, because as I do that one, this one just be taking me to now analyze frequency. So I want to even put, okay, let me first of all let me put them together. Okay, systolic, diastolic, obesity, and hypertension or hypertensive, and I want to down. Let me share the result. Look at the result now. Can you see how many have systolic hypertension? 19. How many people have diastolic hypertension? 15. Obesity, 3. Now, look at how many people have hypertensive or obese. That is, has at least one of them. You see 25. But try and add 19 plus 15. What does it give you? That's 34 plus 3, 37. But when we did it now, it's only 25 that have at least one of them. That shows that there are some overlap. If you are analyzing this now, there's still other thing I need to do. Now I have to now select together hypertensive, systolic hypertensive, or diastolic hypertensive. Systolic hypertensive or obesity. Diastolic hypertensive or obesity. Does it make sense? So when you, for me to go and fill this gap, this place, let me show you. So that's why you need that building logic. Before you can do reasonable analysis in this sense, you need to understand that the way to work to bring result out. Look at it. Look at this one. So when we are talking of systolic, diastolic, and obesity, let's say this verbal harassment is systolic, this breast caressing is diastolic, and this unwelcome kissing is obesity. Now, what we have, the first one I decided was to define this 18 is the one I say, and all of them, the overlap for all of them is 18, where I say systolic and diastolic and obese, which is one will be in the middle. The next one I was supposed to do now, I need to do, is to do systolic and diastolic. It will be here, where it is. The next one is to do diastolic and obesity. It will be here. The next one to do systolic and obesity. It will be this one. Yes, I mean, all that I just need to do now, when I now had for, I want to know what is remaining. I will now add the intersection of diastolic and systolic and diastolic here, an intersection of all of them, an intersection of systolic and obesity. I will now remove it from how many have systolic hypertension. I will now put the figure here. Because when you just add it together, it will give you all the figure. The same thing you do for the, can you see? For me to, like this, when I analyze for this person, for me to bring out this result, that was what I did. I think we can stop here. I don't know if there's any question. Any question in that sense? What we're doing? Any question? Yes. Who is talking? Dr. Judith. Go on.
Okay, no, sir. No.
Okay.
I missed the last few. I wasn't sure if my network was disconnected.
The last two steps or few sentences. Is it sentences or step I took?
Sentence, as if my screen froze just a few seconds, so I was trying to confirm, but it's not.
Okay, let me show you what I said that it's only, well, what am I doing?
No, sir, I don't have any question.
Okay. Oh, I thought maybe, you say you missed the last sentence. No. Okay, no question, right? Okay. Any question?
No question, sir. Thank you very much, sir.
Okay, this 5 minutes tonight.
Sir, thank you.
Welcome. So at least you have Dr. Judith, all this way now. So you have gotten your package finished now because one thing or the other. Yeah. So I think when you go get your laptop now, you should be able to run all the move around the SPSS. Are we together?
Yes, sir, I am.
Okay. So let's have, okay, I want to, if there's no question, I want to stop recording so that it doesn't make the volume to be big, so that we discuss some other thing. But if there's no question, if there's question, let me know so that you can answer it to be there. Any question from any quarter, any angle, anywhere? Okay, no question. Let me